along. For those of you who are at the ARDC Skilled Workforce Summit in Sydney last month, this is a repeat and elaboration. So you're not getting exactly the same content, but you're certainly getting something that has got the same title. And that was actually more by accident because, well, you know, you submit a presentation to this event, and a few months go past, and you think, oh, there's something else on, I better submit something to that, and you end up submitting almost exactly the same abstract, so you end up giving almost the same talk twice. But this one is a bit longer and a little bit more elaborate, so that's where the benefit goes here. International HPC Certification Forum and Australia and New Zealand contributions. There we go. And what we're looking at here is an initial problem on why we are finding a greater push towards high performance computing, a greater demand towards high performance computing, and as a result, a greater need for training in that area. And we start off with the very well recognised issue of the problem of data size and complexity increasing faster than personal computers are improving. And this is like the initial sort of questionnaire that I give at almost every HPC training session when I get a new group of postgrads and postdocs. They've all come along to sort of like learn how to use these systems, and we do a little bit of a round table. We say, you know, who are you? What is your experience with using these, using sort of like, Linux? What is your research project? Why are you here? And invariably they say, I'm here because my data sets have gotten too big, or my data sets are getting too complex. Many years ago I saw like an initial prelude of this. Went to the Warren Ponds campus of Deakin University, and they had sort of like, your standard compute lab. There was also computers on desks for people to use, and about half of them had A4 pieces of paper stuck on the monitors saying, do not turn off job running. And that was the situation then. So people were sort of finding that there are more people now who are moving or wanting to move in the HPC space because those data sets are increasing. So we have things like, this has been known for a number of decades actually. Helbert and Lopez did a study that in 2011 that showed that data increased from the previous 3 decades, 86 to 27, showed that there would been a 23% per annum increase in storage requirements over that period, and a 28% increase per annum in bidirectional communication. So that's like dating a fair period back. The SKA hasn't quite exploded at expectations. If one looks at Computer World 2011, there was an article there when they were saying that the SKA would use up would effectively double the amount of data that the entire internet was using at the time by 2020. Well, that's next year. I don't think it's going to happen. But certainly, as long as that project continues to develop, we will see these increases in data utilisation, increasing in processing requirements, increasing in storage and volume, and so forth. So, once you've got all this data, what do you need to do? Well, obviously you need to process it, and that's where HPC comes into the realm. Certainly the most efficient way of actually doing that large-scale data processing, certainly the preferred mechanism if you're wanting to scale up. Not necessarily always the easiest thing to use, but that's why we have our training sessions. And there's some good studies on its return of investment. The IDCC released a report earlier this year which it was a 3-year study actually, and was carried out with the US Department of Energy, their Office of Advanced Scientific Computing Research, and a National Nuclear Security Administration. And they use like some macroeconomic modelling and some innovation index, and they found, fairly sophisticated study, they found that the return on investment due to an increase on profits or reduction in costs for high performance computing was a rate of $44 to 1. Which is, so if you want to take that back to the bean counters, of course a lot of this is indirect, right? Your institutions that provide this do not necessarily get that money. It's indirect. We see this in improvements in materials advancements. We see this in health science and so forth. So great return on investment, but not always directly allocated to the research institutions or the bodies that are actually providing that. And I've quoted this one in the past a couple of times. Nascent Sociology, Appon et al., showing, surprisingly, that availability of HPC systems improves the production, improves the output in research. Who knew that if you could compute your data sets faster, that you'd actually get more research papers out of that? The combination of these effects is that high performance computing systems, I feel, and I've been saying this for a while, is a critical issue. Now, I don't want you to use the mainstream dictionary definitions of what critical issue or criticism implies. It doesn't mean negative commentary, but rather it's it is something which means that it's a matter of existential risk for organisations. If you do not provide high performance computing facilities and you do not have your researchers using it, then other bodies which do will get their research done faster and your organisation will die. That's how serious it is. So when we refer to a critical issue in the health system of a body, we are talking about has the body got the self-capacity to heal? When we talk about it in literature, we're talking about that point in a narrative, where the antagonist and the protagonist are at loggerheads, and you'll find a resolution there. When you talk about political systems, does the political system have the capacity to maintain its own integrity? It's that sort of critical issue. And it's a critical issue for higher education institutions on whether they are providing high performance computing facilities. So the problem is that we've had a good solid generation and a half of people who've gone through education systems of various sorts and their familiarity with computing, and they have not come from the sort of background where their skill set in computation is the sort of skill set that leads them easily into a high performance computing space. They are more used to using a GUI as their first port of call, if interacting with the operating system. They have a great deal of they have a great deal of knowledge about specific tools that take advantage of some of the things that such an interface can provide. And when there was the presentation at ARDC, one of the questions that was asked of one of the international guests, Hugh Shananan from the University of London, was, don't you think that we could get some modern tools rather than having to learn these 30-plus-year-old commands? Hugh responded quite bluntly, "Oh, don't be ridiculous and grow up," which was harsh and fast. But to a degree, there is some truth there, because these tools have changed in the past 30-odd years. They have been improved. They have incrementally developed, and they are the most efficient and most effective way of actually operating in this space. So, whilst researchers don't necessarily have the skills in the environment, we have a situation where uptake is improving, but but it's still lower than the sort of demand and expectation. So there is a risk of actually falling behind the needs of HPC and the number of people who can take it up. The approach that says, oh, let's make the tools easier is overlooking probably one of the most important components of this environment. And also it actually illustrates that perhaps some people are not quite familiar in why you develop a GUI type interface to begin with. And that is because you want to simplify a process. Now the problem is, when you're dealing with a lot of these computational tasks, well, the process can't be simplified. It's already at its point of simplification. It's do you improve do you skill up the user, or do you dumb down the interface? And the answer is, well, we're going to have to skill up the users. That's unless you can think of some way of actually incorporating all that complexity in a manner which is simple. Well, no, you really can't go down there. So we are in a realm where we actually have to improve HPC training. Now, this normally gets dumped on the actual HPC training centres themselves. You will find in this higher education environment in Australia, there's very few courses in the formal curriculum. HPC training really actually isn't that difficult to give most researchers the tools they need to actually do their large-scale computational problems. They need to work a bit on their workflow. They need to know about the environment. They need to know how to do job submission. They need to know about getting their data close to where the computer is. There's some basic computer science and information science things that they have to pick up along the direction. But that's a part of the problem. The expectation is, within the formal curriculum, is that somewhere they will pick it up, and it doesn't actually happen. So you do get situations where postgrads are turning up to training courses run by providers, and they say, I actually haven't really done this at all. And the HPC centres are the bodies that typically have to actually carry that and try to get people through. Which, to an extent, is a good, is an obvious and good thing which they do carry out, because they know if they have trained users, they will get more educated questions in their various help desk systems and what have you. So there is a fairly obvious cost benefit that they will receive for providing that training. The fact that they are offered through multiple institutions does suggest, however, that there is a bit of an inconsistency in the content and the approach, despite the fact, and although we know that every single HPC system in the world is somewhat different to its neighbours, there is a high level of homogeneity between them. There is a common operating environment. We know that nearly every single one of them under the sun will use Linux or a Unix variant as its core operating system, at least 500 out of 500 of the top 500. That seems to be a fairly good number. We know that despite the variations in job submission tools, that they have got a great deal of similarity as well. Ultimately, all of them are saying, hey user, please request some resources, request it for a period of time, access a particular type of software, run your set of commands. Most of them will be operating with a type of environment modules, because nearly every single HPC system on the planet does not just have a single installation of a particular application. They have multiple installations. They're going to be using the TCL-based modules, or they're going to be using LMOD or something like that. Very similar in many regards, some specific differences, such as the way they do their accounts or what have you. Maybe they actually will have, they'll have scheduler directives that point out those particular things, or the particular partitions or queues that they have, but core concepts are similar overall. One of the issues, of course, about getting the HPC sites to actually conduct this training is that they don't necessarily have experience in being educators. And that's probably not terribly surprising, nor do we hold this against them. Educators tend not to have HPC experience either. So it's like trying to find the handful of people that have got a bit of both can be quite rare, and this is where you start to having to sort of look at some of the things that core features that we know from advanced adult education. For example, the distinction between, or the continuum between andragogy and pedagogy. That is probably a term which is not familiar to many people in this room because most of you probably come from the HPC background. The main difference there is this is a distinction between childhood education and adult education. In the education space, this has been a common area of discussion for probably the better part of 70 years now. But, they'll look at things like, different motivations, why a person's here, the dynamics in sort of like a classroom environment where the adult learner has got a similar level of sort of like social status, the fact that they've got what they call a future time orientation, the fact that they've got more personal resources and experience to draw upon, they've got their own particular problems they want to get solved, and this leads to changes in delivery as well. So, rather than like doing an instruction form, you've got to do a more collaborative form of education. We have issues of proximal development, the sweet spot in education. Outside of that, the person can't do the task at all. On the other side of it, they don't actually need the educator there. For the educator, they want to sit in that middle place that's like says, I could do this, but I might need might need some help as well. So there's like another continuum there. Various disciplinary learning techniques. I know that most people may have heard the term learning styles. Throw those things out of the window. No empirical evidence to back them at all. It's sort of like astrology for education. There are disciplinary learning styles. Okay, no, we'll accept that, right? You don't teach a person how to dance from a book. Maybe a little bit, but most of it's actually going to be practicing dancing. You don't teach a person, if you want to teach a person how to use computing, well, we find that there's a particular disciplinary learning style to that. We find that the hands-on method is quite useful. We find that small group collaboration is quite useful. So these are particular disciplinary learning styles, the most effective way to impart knowledge and education according to the discipline. And funnily enough, the individuals that are attracted to that, they may have an individual learning style preference which attracts them to the discipline, which leads to better outcomes if the discipline adopts that proper learning technique. It's not the other way around. It's not like, oh, this person's like a book learner, or this person's like an activity learner. Maybe we'll get them to do high performance computing through interpretive dance and they'll learn better that way. No, that doesn't work at all. How do you do things like structured and integrated knowledge? Well, that's approach of scaffolding where you carefully make sure that each step in the learning process, you don't introduce something new until you've covered all the prerequisites, often overlooked, easy to do. Formative and summative assessment. What are you trying to do? What are you trying to assess? We find that continuous assessment is a very useful tool to help the learner understand where they are up to in the learning process. It seeks to generate the right answer. Are you getting this correct? That's fairly handy as well. The idea of 3-hour exams where a person is isolated, stuck in a little room, is a ludicrous way of actually trying to teach a person how to use or to evaluate how good a person is at high performance computing. We won't want to use that. We go to summative assessment where you actually are testing their knowledge of the concepts. So anyway, these variation in teaching techniques, this variation in abilities amongst HPC sites and their educators leads to a suboptimal level of training, which of course is a massive issue when you actually have more demand. What do we need to do? Well, we need to sort of bring these resources together. We need to sort of like find, given a level of homogeneity, given us like reasonable knowledge that people, that there is out there in the higher education space, perhaps we can bring it together. So there's the International HPC Certification Forum. Its inaugural meeting was at the International Supercomputing Conference in Frankfurt in 2018. It has its own little bit of history. There was the Performance Conscious HPC, which was an initiative at Hamburg in Germany. That was basically a number of institutions, the German Climate Computing Centre, the Regional Compute Centre at the University of Hamburg, and the Technische Universität of Hamburg, basically got together and wanted to build an HPC competency centre. The Germans are very, very keen on this notion of competency in the same way that we, the Anglophone world often talks about terms of innovation. They like to sort of, make sure that everybody's at a level of competency. Initially started off with skill trees, structured approach of having different skill trees, and within those skill trees there were subcategories with leaves of knowledge or branches, or competency branches and leaves with those branches. There's about 100 different 100 plus different subject components which they're wanting to ensure that people have got competency in. So that's quite detailed. You can look up on their website and have a look at the skill tree which they've built in a little XML diagram and the levels that they've got there. One of the things that they are quite keen on is that they want to have a strong separation between the exams which they want to run and the actual delivery of the content. They don't want to be an education provider as such, rather an examination centre. However, wanting to build up an ecosystem where people contribute to this, they're offering their certification that will include endorsed training materials. So, you can have your little, advertise your training session. There's a nice little starburst on it that says, this includes, competencies for these subjects in the International HPC Certification Program. So that helps build up that material and builds up further interest in that. Here's an outline of some of the initial skill tree and branches and some, and I really do repeat, some of the skill leaves. I tried to initially put up the full thing, and no, it was just absolutely impossible to include all the leaves in there. They also do differentiate the leaves with different levels of training as well. So there's a basic, intermediate and expert level. And in addition, there has been the development of 2 new branches, one for administration and one for big data. So they're building up piece by piece on that. They are largely at the point at completing the skill leaves, which is a good sign. Although there is the possibility that they may need to split up the one which I'm actually responsible for as topic chair, the HPC knowledge, because there is just so much in there. The Competency Centre, so they did a lot of the initial work on getting the initial steps done here, but it has developed a lot further from there. And they're working alongside and with groups like PRACE, the European Centre for advanced computing education, the Barcelona Supercomputing Centre too has a fairly extensive education program, so they'll be working alongside that as well. And of course they'll be doing, they've been doing papers at supercomputing, and also there's been a couple of publications on the Journal of Scientific Computing Journal of Computer Science Education as well. So What about Australia and New Zealand? How are we contributing to this? Well, we got involved way back last year, 1 year, way back then, ancient history, and I got roped in to be the topic chair for the HPC knowledge, and have followed up on that for since then. Also, Wasim Kemla from the University of Adelaide has taken up the topic chair of software development as well. We have our regular, monthly board meetings, so I conduct it over Slack. And Backhouse also attends those with some alarming regularity as well. So we have got some significant Australian New Zealand contributions. After the 2018 e-research 2018 e-research conference, Australasian e-research conference we had the HPC sysadmins workshop day, which was a little bit like a meeting of Alcoholics Anonymous. People would discover they had the same problems. You'd start off, my name's Steve and I've been an HPC admin for 5 years. I've discovered that users don't read the documentation. After that, we had a Zoom meeting with people from various Australian institutions in New Zealand as well. And from that, we've basically built up that category of interest, and that's basically how Wasim got involved as well from that initial meeting. There has also been some work done, very, very new work, just in the past, 6 weeks or so, to do development of some local work as well. So building up local resources for teaching, for contributions of content to the for HPC delivery, assessment methods as well. And that's gradually being built up right now, and hopefully that will feed into content on the forum as well. So you can jump onto the maybe that URL there. We've got a very cute logo that we've built that I've nicked from a former airline that shows a kangaroo and a kiwi looking gloriously in to the stars, where HPC education can develop. Again, fairly new. We've got a handful of people who are basically part of the team, but we're hoping that over the next year or so we can actually build up quite a solid body of content, examinational methods, and educational hints and tools on how we can actually do HPC education in Australia and New Zealand in a manner that is quite collaborative. As for the forum themselves, I would be very surprised if they don't get their first complete draft of the skill tree, at least at the basic level, done in the next few months. They are quite literally that close. The grand hope would be that they would have it done by SC in November. That is certainly still, I think, a possibility. After that, we'd be looking at how do you do the certification exam. There's some debate over this. I'm in favour of an approach that uses more summative techniques. The easier, more convenient approach would basically be doing a formative style multiple choice. Maybe we'll see maybe the initial exam will be done in multiple choice, and future exams will become more orientated towards testing people's conceptual knowledge. We'll see how that goes. And also one of the things that they want to do for the actual exams themselves is have PGP key signing for the actual certificate themselves. So, you can basically take that around and ensure that when a person waves a PDF and says, I've passed this exam, that it is actually the genuine article. One of the things I'd like to organise in the next year or so is to have an HPC, Australia New Zealand HPC educators workshop and hackathon, a sort of forum where, the huge numbers of HPC educators across the country, probably all of about 20 of us, can get together and actually work through content, share stories about how that has gone, and perhaps make some contributions upstream to the international forum. Maybe this will be done, I don't know, maybe under the HPC Advisory Council's aegis, or maybe the ARDC. We're not going to be too picky on which conference wants to attach themselves to such a workshop, because, well, there isn't a huge numbers of us. Bucket load of references there. I may even add a few more as well, and update the slides and fire them off to Sydney, and so you'll be able to get even a more elaborate collection of material. I'd like to thank Anne from Palsy Supercomputer, Roger from NCI, and Wasim who gave this presentation an initial review, University of Melbourne, who kindly sent me over here, and the International HPC Certification in Peacock, which were supported by the German Research Foundation. And hopefully I have completed this presentation in good time. Thank you very much.